Good morning, pre-calculus. Today is something new, partial fraction decomposition. This is something you probably haven't seen before. It's an important little skill. I know we've dealt some awkward topics about these rational functions, but in this one, partial fractions is a way to try to make rational functions a little bit easier to deal with. And the idea is we want to decompose them. We want to break them up into lots of other smaller, easier to deal with rational functions. Let's take a look at an example. So let's consider the rational expression 5x minus 1 over x squared minus 2x minus 15. Now, what partial fractions is all about, the idea is I want to take this and break it up into other fractions so that if I added them all up, I would get this. One of the keys is in factoring. If I take a closer look at the denominator here, it's going to factor nice and easy. And I would get 5x minus 1 over x, let's see, I want to minus 5x plus 3. This is the same thing as this, just broken down. So now I want to be able to break this up into two fractions added together. One of them over the factor of x minus 5, and the other over the factor of x plus 3. So what would I have to have here and here so that if I found a common denominator and added them together, I would get this? Well, the unknown numbers here, I'm going to call them a and b. So the idea now is that I have to find this a and this b. So that if I took this one and multiplied this by x plus 3 over x plus 3 times the a, and then this one by x minus 5 over x minus 5 times the b, and combined them, I'd have a common denominator, and I would get this. So we're used to doing it this way, where I've got something, 4 over that plus 7 over that, multiply, get a common denominator, multiply, get combine them, and rewrite it. We're used to doing this. This was very difficult. We first saw it in Algebra 2. College algebra, very difficult. But now it's all backwards. We're trying to find the a and the b. All right, so let's take a look at this. So here it is. I know that there's going to be two numbers, a and b, such that this function is going to break down into those two partial fractions. This might seem like there's too many variables for one equation. We've got x's and a's and b's. And you're right. There is no nice, easy way to solve for a and for b or for x. What we're going to do, there's two different methods here. I'm going to use one method early on, and then I'll introduce the second method a little bit later. I'm going to make all of the denominators go away. This is a trick we know, we often use, by multiplying the entire equation by the common denominators of x minus 5 and x plus 3. So I'm going to multiply it here, and there, and there. And when I do, multiply by this, the x minus 5s and the x plus 3s will cancel. I'm going to left with just the 5x minus 1. When I multiply it here, the x minus 5s cancel, and I have a times x plus 3. And when I multiply it over here, the x plus 3's cancel, and I'm going to have b times x minus 5. Again, you're looking at this thinking, well, there's still too many variables. How do we solve a single equation that's got 3 variables in it? It's a good question, and there is a couple of different methods to do this, and we're going to look at the first method here. What I'm going to do is I'm going to simplify this side. I'm going to break it up into a whole bunch of different terms. So 5x minus 1, leave that side alone, distribute. I get ax plus 3a, distribute here, plus bx minus 5b. I'm going to group the x terms together. 5x minus 1 equals ax plus bx, and the ones that don't have any variables, 3a minus 5b. I'm going to factor. So I'm going to have 5x minus 1 equals a plus b times x plus 3a minus 5b. Now here comes the trick of it. What we're going to do is something called matching coefficients. I'm going to match up the coefficients. Here's the coefficient of x on the right. Here's the coefficient of x on the left. Here's the constant on the left. Here's the constant on the right. In other words, the 5 has to be a plus b. And the negative 1 has to be 3a minus 5b. Now take a look at what we've created. We've created a little system of equations. I've got this little system of equations here. Two equations with two variables. And I need to solve for the a and the b. And don't forget, the a and the b represent the numerators from the partial fraction decomposition. So how can I solve this? A lot of different ways of solving this system here. I'm going to leave this equation alone. Just bring it down. Negative 1 equals 3a minus 5b. And this equation, I notice that I've got a negative 5, and I'm going to multiply everything by 5. And I'm going to get 25 equals 5a plus 5b. So when I add them together, the b's will be eliminated. And I'll have 24 equals 8a. Divide both sides by 8. And a is equal to 3. That's the numerator of one of my original partial fractions. Now I need to find the b value. Well, it seems like this would be my best. 5 equals a plus b. But I know what a is. It's 3. 5 equals 3 plus b. My b is equal to 2. So if I go back to the original equation, as I broke it down, I now know that 5x minus 1 over x minus 5, x plus 3, is equal to my a value, which was 3 over x minus 5, plus my b value, which was 2 over x plus 3. And there it is. We've broken this down into two partial fractions. Now it will get harder, and there's some twists along the way. Let's take a look at another example here, something a little bit harder. This one's going to have another bit of a twist in it, and we're still going to use that one method here. So in this one, I'm going to have I want to find the partial fraction decomposition of negative x squared plus 2x plus 4 over x cubed minus 4x squared plus 4x. Factor the denominator. I can factor an x out of there, and then I would have x squared minus 4x plus 4, which also factors. When all the factoring is done, we should have x and x minus 2, x minus 2. So now, as I break down this, because I've got a repeated quadratic factor, repeated linear factor rather, I've got this repeated linear factor. My partial fraction decomposition is going to look a little bit different. I'm going to have something over x plus something else over x minus 2, but there's more to it than that. Because if I just had this, the common denominator would be x times x minus 2. Where's the other x minus 2? So I'm going to have something else over x minus 2 times x minus 2. Oh gosh, running out of room. Sorry about that. I have to have it repeated down here. Now, it's entirely possible that b could be 0 and then I just have this and this, but I have to have at least two of those and that. So I've got three numbers that I need to solve for here. Three numbers. Because of the repeated linear factor, I'm going to have it here once and then there twice. I'm going to use the same trick, multiply everything by the common denominator. So if I multiply everything by the common denominator of x and x minus 2 and another x minus 2 and multiply it in. The denominator here is going to go away. I'm going to get negative x squared plus 2x plus 4 equals a times, well, the x's cancel, and then I'm going to have x minus 2 and another x minus 2 plus b times, the x minus 2's cancel, but I'm going to have an x and an x minus 2 plus c times just an x. Both of the x minus 2's cancel. So same strategy here. We're going to break it all up and match up the coefficients. So a little bit of algebra here. Here we go. Negative x squared plus 2x plus 4 equals, if I FOIL those out, I'm going to get x squared minus 4x plus 4. If I distribute the a, I will get ax squared, and then minus 4ax and plus 4a, plus bx times x is bx squared. Bx times negative 2 is negative 2bx plus cx. Group them together. I want to match up the coefficients. Negative x squared plus 2x plus 4 equals ax squareds plus bx squareds. Get my x squareds together. Plus my x's together. I've got a negative 4ax. The 4a is going to be a part of a constant. Minus 2bx plus cx plus 4a. Factoring here so I can match up the coefficients. I'm going to have negative x squared plus 2x plus 4 equals a plus b x squared. That a plus b is going to match up to a negative 1 plus negative 4a minus 2b plus c times x, and that's going to line up to 2, plus 4a, and that's going to match up to the 4. So if I look at my what matches up to what now, and write my little system of equations, the first thing that I've got is that coefficient of the x squared, coefficient of the x squared. That means negative 1 is equal to a plus b. The coefficient of x, the coefficient of x, that means that 2 is equal to negative 4a minus 2b plus c. And then finally, the constant matches up to the constant. 4 equals 4a. Here I've got a system with 3 equations with 3 variables. I don't want the system to be the hardest part of solving this thing. You're not going to see too many really crazy systems here. In fact, this one kind of resolves itself, relatively quickly here if we kind of work this one through. Here, my first equation, 4 equals 4a, then a equals 1. Using this equation, negative 1 equals a, which is 1, plus b, subtract 1 from both sides, b equals negative 2. And then using this equation, 2 equals negative 4 times a, which is 1, minus 2 times b, which is negative 2, plus c. 2 equals negative 4, minus 4 plus c. 2 equals negative 8 plus c. Add 8 to both sides. C is equal to 10. So now as I write this all out, oh, did you catch the mistake? I made a mistake here. Negative 2 times negative 2, that's a positive 4. So that's going to cancel there. And my c, oh, I'm not going to start the video again. I make mistakes along the way. Let's just kind of deal with it. So c is equal to 2. So c is equal to 2. My a is equal to 1, my b is negative 2, and my c is equal to 2. So what does that mean? From my original partial fraction decomposition, that means that negative x squared plus 2x plus 4 over x times x minus 2 times x minus 2 is equal to my a value, which was 1 over x, plus my b value, which was negative 2 over x minus 2, plus my c value, which was positive 2 over x minus 2, x minus 2. There it is. So the repeated linear factor is just one of the issues. Take a look at the first couple ones in the homework assignment. Do the first ones there, and then we'll look at another issue that could come along, and we'll look at a whole nother method for solving these. All right, so take a look at the first few homework problems, about 15-20 minutes, and then I'll join you again, and we'll look at some more examples and other issues that come up.